Hello there, let's talk about finding the area of a triangle. So for years and years you've been using the area of a triangle is half base times height, where the base and height are at right angles to each other. So when you have a right angle triangle, that's really easy to see. These two sides are at right angles to each other, so they must be the base and the height. And then even in this triangle, where it's not a right angle triangle, we get told the height and the base. So essentially, in finding the area of a triangle, we need to know the base and the height. The height is always right angles to the base. So you need to know those two measurements. So here's the formula we can use to find it. Basically, we've used Pythagoras' theorem to find it. It's been simplified to area equals half BC sine A. You might see it in other ways written out. But basically, as you can see from our example, we've got this triangle here where we know two measurements and the angle between them. But to figure out the height, we need to know that there. Okay, we need to know the right angled length. The right angled length, this height. So looking at this original triangle, it's not drawn very well, but I'm sure you can excuse me. 10, 32 degrees. Looking at that, and we want to figure out that unknown there, I might actually just label that X. That height, we've got an angle there, the hypotenuse. We want to know the opposite the opposite side. So thinking back to our ratios and our Pythag, so that is sine 32 degrees equals X on 10. So X equals 10 times by sine 32 degrees. You can see, okay, well that's where that part's come from, isn't it? That's where that's come from. Okay. And you can see it all worked out here as well. Okay. So you need to know the side or two sides and the angle between them in order to use this formula. Okay. Now this formula, it's actually, a pretty nice formula to use. So find the area of the triangle correct to two decimal places. So write out the formula. There's my triangle. Putting my knowns and unknowns, and that's what I get. Okay. Here's from the 2005 further maths exam. So we've got two sides and the angle between them. The area of triangle PQR is closest to. Okay, so area equals half times B, C, sine A. Okay, so area equals half times 10 times 5 times sine 25 degrees. And popping all of that in. So I'll put that as a decimal because all the answers are decimal. 0.5 times by 10 times by 5 times by sine 25 degrees, approximately equal to 10.566. So that is closest to C. Okay, let's do question 1 from your textbook. So this is exercise 20.4, question 1. Find the area of a triangle, ABC with side A equals 7, side B equals 4, and angle C equals 68. Now, remembering with our labelling that angle C is going to be between A and B. Okay, so it's that included angle. So you've got to be reading these really carefully. I'm not drawing this very well, but it's just really to help me understand. And I hope you all draw out the triangles, because it's really important that you draw the triangles, even with these simple ones that we start with. So area equals half times B times C times by sine A. That's just the general formula, and then we can put in our knowns and unknowns. Times by 4 times by 7 times by sine 68 degrees. So area equals, so it's up to you whether you put a fraction or a decimal. I chose a decimal with that first one we did because the answers were in decimals, so putting in a decimals forces it to be a decimal if you've got your CAS in auto mode. Times 4 times 7 times sine 68 degrees, and I go approximately equals to 12.9806. It doesn't give me a rounding instruction, how a degree of accuracy. So depending on what the book says, it probably, because all the rest are to the nearest whole number, we might say that is 13. Okay, I might leave this one. Now, that formula is pretty straightforward to use and pretty quick. I'm sure you'll agree. Now, we can only use it though if we know some internal angles. But if we don't know internal angles, but we do know all three sides, we can use Heron's formula. Okay, we can use Heron's formula. So you've probably used this before, where area is this square root of S times by S take A times by S times take B times by S take C. Now S is something called the semi-perimeter. So there's a number of steps you've got to do here to calculate it using the Heron's formula. So I usually suggest, if you have any of the internal angles, see if there's a way you can use this one, even if you might do a bit of working backwards, from working out some of the other angles, but if you're given all three sides and no internal angles, Heron's formula's the best. But just see, it really depends on the question. So here, this example, find the area of triangle PQR, correct to one decimal place, given P equals 6, Q equals 9, and R equals 4, and all these measurements are in centimetres. Please make note that whenever you're doing any of these calculations, all of your units have to be the same. It sounds really obvious, but if one's in centimetres and another's in millimetres, then you're going to get a mismatch. It's not going to work. You have to have them all the same unit. Okay, so our first step is to work out our semi-perimeter. So 6 plus 9 plus 4 divided by 2 is 9.5. Then our area calculation. We get A equals the square root of 9.5 times by 9.5 take 6, 9.5 take 9, 9.5 take 4. All the way down until we can get this. A is approximately 9.6. So from the 2006 further maths exam, we get given this information. A block of land is triangular in shape. The three sides measure 36 metres, 56 metres and 42 metres. To calculate the area, Heron's formula is used. The correct application of Heron's formula for this triangle is... Okay, so we don't have to work it out here, but we have to figure out, well, which one of these is the correct use of Heron's formula. So S equals 36 plus 58 plus 42 divided by 2. So S equals, yes, I'll pop that in the calculator, 36 plus 58 plus. Now notice that most of the time I write things down as well as doing them in the calculator. That's so I can double check things. And also if this was questioning a test or something, or an extended response question, you might need to be showing, your thinkings. Okay, so we figured out that S is 68. So that's a starting point, isn't it? I know it can't be A, can't be B, because they're saying S is 136. What do you think they did wrong there? Yeah, they didn't divide by 2. And looking at these also, it can't be E because they've got that 136 there. Okay, so it's either C or D. Okay, so NXC, isn't it? Because that's using the actual side measurements. We've got those there, which I'm not entirely sure what they are. But anyway, so X would be answer C there. Okay, so let's do one from the textbook. Let's do question 9. Okay, so question 9. Find the area of the triangle with sides of 40 millimetres, 30 millimetres and 5.7 centimetres. Now, because 2 out of the 3 are in millimetres, I'll probably convert that to millimetres. You might be told which way to answer it. You might be told we're finding it in centimetres squared or in millimetres squared. So just depends on the question. So find the area. Okay, so let's say 40 millimetres, 30 millimeters, and of course that is 57 millimeters. Okay, so S equals 40 plus 30 plus 57 divided by 2. S equals, okay, 40 plus 30 plus 57 over 2. Oops. I might find that. Okay, so that's 63.5. So my area is square root 63.5 times by 63.5, take 30 63.5, take 40, and 63.5, take 57. Okay. You can see why this one takes, a few more steps and a few more things that you could make a mistake on. Okay. So I'm going to start with the square root times by 63.5, take 30 times by, please don't forget to put those times by in. Sometimes the CAS calculator works out that you mean to times things together, but occasionally there's things where it doesn't. So it's a really good habit to get into, that no matter what, put those times in. Okay, just double checking that I've got all that right. And answer. So 570.033 square millimeters. So 570 square millimeters if I'm round, not having decimal places. Okay, now I haven't looked what the answer is. It could be in square centimeters. Another little thing I like to do is I usually, rather than waiting till the end and then changing the area, changing from millimeter squared to centimeter squared, I usually try to do it at the start and change those lengths, because it's a bit easier to do, isn't it? So yes, that is area of a triangle.